Herein we can start with finding out the acute theta. In the last part, when we discussed, when we introduced the trigonometric ratio, we had taken up the direct questions wherein you are given the measurements of the theta. You had to apply the values and find the answer, or maybe few proofs to be done. But herein, let us take up questions like, I write up, it says, find an acute theta where cos, this is a kind of a converse question actually. You have to find theta. The previous part we had taken the thetas given, we were just supposed to find the values. It's given, we have to find the theta for this is equal to 1 minus root 3, 1 plus root 3. I assume you know about what is component to dividendo. I will apply there are two methods actually of if anybody wants to solve this, but I'll be taking up the component to dividendo method, wherein I will be applying that theorem that gives me the numerator is added to the denominator and again this is added the denominator is actually added to the negative of the numerator. Yes, okay. I'm just taking the left hand side now. It is given that, we were given that cos theta minus sin theta. It is given, so this must be equal to, I've put the component to dividend on the left hand side. This is equal to, otherwise you know, if anybody doesn't want to apply component to dividendo, can actually use a cos theta to divide both the numerator. In that case she'll be getting 1 minus tan theta here, and then 1 plus tan theta in that case. So but I'm taking this up, and if I remove the bracket, my sin thetas, this two gets cancelled, and I'm getting a cos theta, right? Yeah, so that will give me 2 cos theta, and in the denominator I think my cos theta get cancelled. I'm getting a minus 2 sin theta. That's equal to kind of 2 getting cancelled. I'm getting a 2. This was actually equal to, if I remove even this part, I forgot to write the same on the right side as well. This plus 1 plus root 3, and this will be minus and negative of it, the same theorem. And on that side I will be getting a 2, because root 3 once remove the bracket it will get cancelled. Here 1 will get cancelled, so I'm getting a minus 2 root 3 as well, right? In that case, see this 2 minus 2 getting cancelled. I'm getting a cos theta upon sin theta, which is a cot theta, and I'm left with a 1 by root 3. If you look at the trigonometric ratios table, cot theta is 1 by 3 is or you can simply write this if you cannot recall, but that's 1 by root 3 I think is given at theta 60 degrees. So either you convert it into tan theta, which is root 3, and you recall, or you can recall it here. So theta will be 60 degrees here. Okay. Now I will be taking up a word problem based on this trigonometric ratios. Let me just write down the question. It says an lateral triangle is inscribed in a circle. I could have increased the font, but it's okay, I can read it. In a circle of radius 6 centimeter, find its side. Let me just draw this figure. It says there is a circle. There is an equilateral triangle. I will try to make one. Doesn't look like. Just give me a second. I'll try to make, though not accurate one, but at least it looks like an equilateral triangle. Yeah, this looks more like one. Let me name this. Maybe A. This is B. This is C. I have to draw the center as well, maybe here. I also join this center with OA and OB, OC, and then I drop. I join OA. That's also a radius. Oh, I haven't even named it. This O, but this is O. I'll drop a perpendicular from O to D. Oh, I hope it looks like one. Yeah. And this will be D. Okay. It says the radius is 6 centimeters. So our OA equals OB equals OC. They're all 6 centimeters. Now, if I have dropped a perpendicular, this is, oh my god, this is perpendicular. And as because I have dropped a perpendicular to the side, then D becomes the midpoint, because this is an isosceles triangle. If I am dropping a perpendicular, that becomes the midpoint. This is D. That means BD is equal to DC. So angle B and angle C is being respectively bisected by OB and OC. Do I note it down? Do you want me to write? Let me just write. See, what I mean is D is, I said, the midpoint of BC, and I said D is midpoint. I also informed that this OB and OC are the bisectors of angle B and angle C. If they are bisectors, see, it was kind of they have informed that it was an equilateral triangle. So this whole was 60. This whole was 60. In that case, if OB is the bisector, this small angle values will be divided by 2. So 30 each. Right? So angle OBD is equal to 30. I'm concentrating on these triangles. I'm writing OBD 30. I'm writing BD. Oh no, we don't know BD actually. We need to calculate BD. Then only we can calculate BC, because BD is half of BC. We have to find its side, means either I find BC, AB or AC. I'm concentrating to find the BC part. So BD can be calculated, and obviously we need BC. That's right. In this triangle we also know OB, which which is given by 6 centimeter. Now we will applying the trigonometric ratio to find BD. As because we know OB, we need to find BD, which if in this triangle is actually base and hypotenuse. So base and hypotenuse relation is given by cos. So let us just take up cos, and this angle we are taking, so it is cos theta, that is cos 30, is base by hypotenuse, that giving us BD by actually OB. So cos 30 is equal to, BD will be cos 30 and OB into cos, I'll correct it, OB into cos 60. OB is given by cos 30. OB was given by 6 centimeter, and cos 30, if I recall, is root 3 upon 2. So I'm getting it as 3 root 3. Now this is given by BD. BC, as because BD was half of it, D was a midpoint, so BC will be twice of BD. So it is 2 into 3 root 3. That's giving us 6 root 3 centimeter, right? There can be various other applications as well. Let me just take up one more question. The next one, though, what I suggest can be given to you. I'll just discuss how to go for it, and you try and solve by yourself. Let me just write the question. I'll obviously not be giving you any difficult question, for the time being. We will though later on discuss those hot questions, hot board questions. Okay, a rhombus which is given of side 20 centimeter has two angles of 60 degree each. Find the length of the diagonals. Okay, let me just discuss this question and leave it to you. Suppose this is your rhombus, as they say. They don't look like equal. Yeah, now if I draw it like this, it would clean it up. Name them. All the sides are 20 centimeter. Two angles are 60. Find the length of the diagonals. The diagonals are BD and AC. Now, which two angles we take to be 60? Let us take this. Sorry. Yeah, this BAD. Let us take BAD to be 60, and another angle we have to say take. So we can take BCD to be 60. Right? You can take BAD and BCD to be 60. Aren't the diagonals of the rhombus are perpendicular bisectors? So in that case, AC and BD are bisecting these two angles which I have already marked. These were 60. In that case, this becomes 30. Right? This is the basic information, right? Now that means what? These are when I said the perpendicular bisector, that means they are making 90 degrees here, that thereby making all these four triangles right angle triangle. Now you simply have to find BD and AC. To do so, okay, if I join, let me just name the point of intersection at the center, that is O. Now take any of this right triangle, you know, maybe BOA. You have this side been given, you have been given this angle theta. Find the relation and get OA, right? AC will be twice of OA. On the other hand, you can take this triangle, similarly find OD. BD will actually be twice of OD. Thereby you will get the two diagonals. Do I give you the answers for you to check? Okay, let me just give you. You will get AC as, I think, 20 root 3. You might get BD as, obviously they will not be equal, being the diagonals are not equal in a rhombus. This many centimeter you will get here, and you'll get, hope you get them correct. Thank you.